My name's Robert Bennett, and I'm from the University of Southern Mississippi. I work in the Tim Rollins Research Group, and my poster is mainly about looking at how free films are affected by sodium chloride concentration due to affecting the water absorption, the ion exchange between the solution and the coating, as well as the morphology of the zinc phosphate pigment within it. So we have a drawn down coating, removed 4.7 millimeter discs were punched out of it, immersed in 10 mils of solution containing no salt, 0.25% salt, 3 weight percent salt, and 5 weight percent salt. After 3 days immersion, we performed TGA to look at the amount of mass that was lost, which with increasing sodium chloride concentration, there's not much of a change in weight loss, but with DI water, we had the largest amount of water loss. So we believe that that's because the chlorine and the sodium were taking up actual space within the coating. Now, we performed ICP and IC to actually look at the exchange of those ions from the solution into the coating and from the coating back into the solution. So as salt concentration increased, more sodium and more chloride left out of the solution into the coating, and more zinc and phosphorus left out of the coating into the solution. EDS was used to actually qualitatively confirm these results. So for 0 and 0.25, we see no sodium or any chloride, but at 3 and 5, we see a sodium peak for 3 weight percent and sodium and chloride for 5 weight percent, which proves that this results here in the ICP was correct. And then following it all up with SEM, we were able to actually take images of the coatings and look at how the morphology changes with different chloride concentrations. So it starts off as a certain shape, and then as chlorine is added due to this immersion study, we see the shape and the size of those crystals change as well. So all in all, this is useful when applied on a steel substrate or any form of metal substrate. We can see that non-isometric is preferable to isometric, so the actual morphology of this zinc phosphate crystal is useful for the water permeation into that coating eventually reaching the substrate.